This lab we test for the component level testing. This is for the component level reliability testing, including the semiconductors in the high temperature over 150 degrees C for 1,000 hours to qualify the semiconductors.
1,000 hours?
Yes.
150 degrees?
Yeah. Make sure they can meet very high-end standard.
You run a test now, huh?
Yeah. We have a very high voltage here and increase step by step.
Some people asked me when I did this capacitor testing on my site and YouTube channel, some people asked me, does this test shows the quality of the capacitor?
Yeah, sure.
High quality means it's tolerant to high voltage.
We use the same condition to qualify every...
Based on this test?
Yes. So the same criteria for all. So the robust will be very easily confirmed.
Confirmed without having to use 2,000 hours in an oven, spending all that electricity. Just a simple test like that.
A couple of hours, we can see who is the best, who is the worst.
This is what I wanted to hear from you, since you are an expert in this stuff. You do that for many years now.
Yes, we have developed this kind of testing over 10 years.
10 years?
Yes.
Wow. So for 10 years you researched to come up that this is a very good test.
Yes.
Quick test to check the reliability and the quality of capacitors.
Yes.
Okay. That's what I want. I wrote my own code for that, my own program. Something similar that you do, I just use different voltage levels.
Yeah. So that kind of capacitor have a higher challenge for the suppliers.
According to your data, if you can share, which semiconductor company is the best now? Infinity, Visai?
Based on our experience, Infineon is the best.
Infineon is the best, huh?
Yes. Come from Germany.
From Germany, Infineon, Germany.
Yes.
Wow. Okay, that's good. That's very good to know. Infineon, I have very high regard of Infineon.
Yeah, very good reputation.
Very good, In the MOSFETs, now you have also started testing MOSFETs, right?
Yes.
130 degrees, 85 humidity. When the test finishes, 200 hours, the MOSFETs and everything that's inside. They have them out, test them to see if they operate. But in the future, they will also apply voltage inside, so they will know real time when they will fail. And the test must be quicker than 200 hours.
Yeah, and find the problem earlier.
Yeah, earlier.
Yeah.
You don't have to run the full time.
Yes. This lab we test for the EMI and the EMC testing.
EMI,
for the lightning surge, and for the EMI, we collect samples for every single production lot.
You just take some random samples, right? And you put them and
random samples. Check EMI. Yes, you can see that here is the conductive EMI.
The limit? You don't have the limit.
Yeah, we have the class B for the server.
The maximum peak, the peak it's much faster. Quasi resonant, it takes hours.
Man. Yeah. Because in the Europe, the EMI, EMC
is very important,
very critical. So every single production lot, we test the EMI and make sure everything is ready for the shipment. If there's anything wrong, we'll stop.
And you use a real system to check it.
Yeah. So that kind of testing, quite kind of like government regulation. Yes.
You cannot get a C.
Yes.
C requires to pass EMI testing. It's very important.
Yes, that's government regulation.
Yeah.
And then we have the air discharge or contact discharge. Simulate the human.
The spikes, All the spikes. This is a server PSU running. Oh my God. So you use it for power supplies here, right?
Yeah, for power supply level. So that's the first lab is for the component level, but this one is power supply level.
That's the final product.
Yes. Yeah.
And how many hours you run the PSU here?
It's about 1,000 hours.
1,000 full load?
Yes. So this one is for the 4,000 power supply, 4,000 watt.
4,000?
Yeah, it's for the GPU application.
This is a 4,000. server PSU used for GPU applications. I'm not afraid of NVIDIA.
Consider testing in Europe as you wish.
4,000 watt. Wow.
Yeah.
We have the capacity. Our loaders can go up to now 7 kilowatt.
Okay.
But it's tiny.
You can see the capacity over here is a very huge.
So this is the capacitor, 3 capacitors together.
Yeah, capacitor.
This is a single capacitor.
Yeah.
All this thing.
Yeah.
Oh my god.
Very big.
EPCOS.
Yeah, because it's a TDK.
TDK. TDK capsule. Okay.
Yes.
Also.
Yes.
Okay.
Yes.
Wow.
So you can see the power supplies. This is the input. This is the output.
Yeah.
And for that's kind of power supply put into a
You
rack.
have special fixtures. Yeah, you have the fixtures.
Yeah. So the AI computer, they consume too much power.
AI, yeah.
Yeah. Like
They also have a long wing here, although it's an older model.
So
yeah, the long wing.
yeah, this lab is majority for the fan testing for the power supply level. So we have the fan keep running in the power supply and record the parameters of the fan. That's kind of testing the purpose is very simple and the impedance of the power supplies. So that kind of testing based on our design phase. We check the parameters of the fan, parameters of the power supplies, and finally we confirm the thermal based on the actual thermocouple testing. So this is the first step. And after the simulation, after the actual sample building, we have the final confirmation by the thermocouple test to test the power supply failure. So we have a different kind of approach.
Maximum full power and 50 degrees Celsius.
Yes. And the test to failure, we just try to destroy the power supply to see where and how the damage.
Destructive testing. This is a shock testing.
Yeah.
Frequency, fast temperature changes.
Yes.
You also vibrated?
Yes.
Oh, okay.
So we can easily find the weakest point.
That's very tough testing here.
Yeah.
But these machines around 24 hours a day.
Wow.
You don't leave them unsupervised. Somebody is here and supervises them.
Yes,
outside.
and we also have the cameras over here.
Yeah, the camera.
Yeah, because that kind of testing take a long time. Okay, so our manufacturing process from SMT manual insertion with soldering, touch-up, assembly, burning, and the packaging. So this is our entire process in this building.
Okay.
Okay, let's go.
You cannot go into production without these clothes.
So this floor is the best in China.
The best, huh?
Best.
The best production line.
Yes, best configuration, high-end equipment, high gas automation for the power supplies. This is the information we can show how the production going and how we manage that kind of process, how we meet the goals. So that's the efficiency control and the customer name.
The model name.
Yeah, model name.
Okay.
The SMT process finished in the second floor assembly with the manual insertion components.
It's manually here.
Yes. We have the fixtures, we have the traceability control, we have the barcode to record every single process and the time and the component numbers. Make sure we have the right component and the right position.
And the time. Also, you monitor the time it takes.
Yes. So we also have the robot to pick up the board. Nobody to manually touch the board and improve the automation. Sometimes the manual insertion or touch up will create a defect. And that kind of automation can avoid that kind of mistake to guarantee the quality.
Holding.
Yeah, we have very few components for
They
the
send them by hand, huh?
yeah, only a few components by manual insertion. So for the power supplies, we have over 1,000 components on the board, but over 95% is SMT and automation. Less than 20 units for the manual insertion.
And the bulk ups by
Yeah,
hand, huh?
yeah. Backup is too big. Here is a CCD test.
CCD.
That's
With the camera, you check if everything is in
yes,
place.
this is the visual inspection. Make sure the capacitor in the right direction.
Because if it's in the other way around, it will go boom.
Yes, exactly.
Yeah, it doesn't allow everything to be inserted the wrong way.
Yes.
Or if it is missing something. Huh?
Yes. The reason was the power density and the component density is very high.
This is wave soldering. This is probably the most important machines. It applies solder to every component. In the previous lines, they were inserting the components by hand. Now the components have to get soldered into the PCB. And this is exactly what this machine does. And look how slowly it moves. That's a voltage. Volt, 400 volt. An amperage. Oh, volt and amps. 400 volt, 27 amps. Wow, that's a lot of power. Let me make the calculation. 27,4. Close to 11,000 watts.
So after the wave soldering, we have the robot pick it up.
Because it's hot.
Yeah.
You have also to do some soldering by hand.
Yes. Just based on solder joint inspection, based on our new generation development design, we can reduce the component numbers, and the quality can be improved a lot. Right?
Yeah.
More component, more failures.
Of course, the less components you use, the better.
Yes. Here is the AOI inspection. That's automatic optical inspection.
Optical inspection. Another optical inspection.
Yes, that's before the wave soldering. That is after the wave soldering.
After.
So you can see our new design. There's no component in the bottom side. The machine can capture the digital camera, digital picture very quickly and compare to the standard picture to see how we control the soldability.
And this shows the deviations?
Yes.
Everything is almost fully automated, as you can see. The quality control is mostly through this machine with the cameras, QR code.
Yes, they scan the code, make sure they can record the manufacturing progress. And this machine is also automation.
They cut the leads, the long leads.
Not least, I mean the PCB remains.
Yeah.
Okay, that's why.
The PCB, it cuts the extra PCB, okay.
Yes.
Another inspection here.
Yeah, this is the final touch-up for the solder joint. And
solder joint.
Yeah. So that kind of inspection just make sure there's no more mistake or no more problems before the chassis assembly. After the chassis assembly,
you cannot
open anything.
Yeah, you cannot do anything.
Yeah.
So another inspection here, human inspection, because machines are cool, but humans also have to check some things.
We have the glue.
The glue.
Yeah.
To avoid cold wine.
Yes, and improve the mechanical strength.
The glue is automatic. You don't put it with hand.
No.
Cool.
That kind of automation can control the location, control the volume.
And it doesn't apply much glue.
No need.
No need.
Yeah.
While in some PSUs, I see tons of glue all over the place. Here, it's only in some specific places, the glue.
This is the advantage of our company, technology.
Before they burn in every PSU, because every power supply gets a burn-in treatment, this is the first test, full test, Chrome 8000 everywhere, fully automated. If you can see, there's a robot taking each of the PSU. Each of the PSU from this line passes through this Chromite 1000. And they use the mesh system also. So they have data in every PSU that it goes out. You don't want to put your hands there. And here, the keyboards and the mice is to control the chromas. Once they are ready, they pack them up and they go to burn in here.
So it's the burn-in test. Right now we exchange the different projects, change the pictures.
How much time you apply the burn-in treatment? How many hours?
Minimum 4 hours.
4 hours.
Yeah.
And 50 degrees Celsius.
Yeah.
And full load, right?
Yes. And we have the additional AC power cycling.
Okay. 4 hours, minimum 4 hours burning, 50 degrees Celsius, and full load.
So new project, we have the 24 hours burning.
24 hours.
And the step-by-step reduction. And finally, it's 4 hours.
Okay. So you start with 24 hours. If you see things are good, drop lower till you go to 4 hours for fully tested production.
Yes.
And here is another test again.
This is the final testing.
The final test.
Yeah.
The units per hour.
Yeah.
Red.
Yeah.
Okay.
And that's our production control.
Initial testing, burn-in, and second test after the burn-in to check if everything is okay. Fully automated again for every PSU, for every single PSU. The only thing that is manual, as you can see, the lady puts the PSUs there, and they are grabbed by the robot arms and they are tested. Ten Chromite 1000, yeah.
Yeah.
And again, CCD test.
Yeah, this is the CCD for the
fan and the...
Yeah, so you can see a lot of different kind of locations of the power supply. This kind of test inspection is not for functional testing. It's for the chassis, the label, and the fan assembly. Making sure that's no mistake. That's assembly for the system, different ID. They have a mechanical design here to match the system. Make sure we put the right chassis.
Okay.
The system level, they have a lot over here.
And the final stage, the packaging. Another visual inspection, human visual inspection. You know the best thing to judge if a PSU is okay or not? You make like that. If you hear a screw getting loose, and this is not only for PSUs, for people also. If you don't hear any sound, it's okay. And it goes to packaging.
Okay, so the production completed over here.
Yeah.
So entire process, we have the box and the
Ready to go to
plate
the client.
over here. And after that, we will go to OQC inspection. That is the quality inspection on behalf of our customers. Okay.
So your customers inspect the product?
Yes.
Okay. Random samples, and these guys here
that
do some sample testing.
Yes.
Random sample testing.
For the liquid current, cosmetic inspection, safety, I2C functional testing, and even some AT chroma testing to make sure everything is correct in our line.
So another round of tests, random.
It's totally different to our production line. It's different.
It's completely
program.
different, yeah.
Make sure we have the right control, independent inspection.
So the guys here are from Great Wall. We test the guys here, Great Wall, right?
Yes.
Okay.
Yeah,
just another department.
Yes, it's my department.
Your department. They don't belong to production. This is the testing department, quality control department.
I am in charge of quality.
And let's say in 1,000 PSUs production, how many do you choose for atom sinking?
So we have a different kind of criteria for different kind of product. Quality goes about 0.65. That's
0.65.
Yeah.
That's quite a large number.
Yeah.
So in total, 400 engineers in this building.
Yeah,
That's quite a lot.
Yes. They test the power supply every day.
So every day these guys they have a PSU to test.
Yes.
Different projects.
Yes. And they modify the components, and then they modify the firmware, and then they change the capacitor, and measure the waveforms. That's the way they test every day, and try to optimize our design, optimize our power supply.
Full modification here.
Yes, to comply with the actual configuration in the field, in the data center.
Yeah.
The customer, they configure a brick over here. We have a fuse design on the board, making sure our fuse can be much faster than the brick when something happens.
Voltage cells, you mean?
Yes, that means our fuse can break first. Make sure there's no trigger.
So that's kind of BCD, automatic delay. So on purpose, you do something on the PSU or voltage cells or something, and you expect the fuse to go out first before this delay jobs.
Yes, yes. The reason was if the brick shut down, the entire data center will
shut down.
Shut down.
So you don't want that. Yeah, you want the PSU itself, the fuse, to go out before.
Faster.
Yeah,
yes. We will see that as damage control.
Oh, okay. That's very smart, actually. Yeah.
Yeah.
Because even a single module can kill the entire, not only this server, but the entire everything. Yeah. You know that you are in a building full of engineers because this guy left a live circuit, 230 volt, completely unattended, and say, okay, nobody will touch it. And all of the engineers are very young.
Yes.
They are very, very young.
Yeah.
They're writing code for the firmware. Huh? That's your tool, that's your software, right?
Yes.
It's custom made, all the software.
Yes.
I hugely admire electronic guys who also dive into coding. Because you have to be a coder and you also have to be an engineer. But this is the best. It's the best. If you're only engineer and you don't know coding, you cannot do anything.
Right.
Especially with the server PSUs who are digital. And I hope at some point that desktop PSUs also will become digital because this is the way. Chris.
Say hello. Say hello.
Chris, God of War.
Yeah, that's Aris. Okay.
This must be a gamer, right?
Yeah. Here is to check the air gap in the soldering. So something.
The soldering?
Yes, something like the chip design. They have the SMT soldering, and after that, there is some air gap inside of the component.
It can create problems in the long run. Yeah.
Yes, so we have the IPC standard to make sure the air gap under control, not too much gaps. That's why not good for the power dissipations.
Yeah.
And some particular area where overheating for the component and easy to be damaged. So we have the random samples from the line and check the suitability for this kind of component. So here you can see another.
That's unbelievable.
Yeah.
This Cayennes.
Yes.
Oh,
so
that's unbelievable.
This kind of testing is about our component review.
Open the IC completely to see inside.
Yeah, we have a chemical and remove the package.
Yeah, only with chemical you can do that. Yeah.
Yes.
it's amazing.
Will you let me play if we buy it?
Yeah, of course.
You can take your time playing.
I want to put a lot of things under there.
Yeah,
I have some ideas.
yeah. Amazing, amazing.
谢谢，
Very
那
nice.
挺好。
Amazing.
嗯。
Take it and run.